Hello teacher, my name is Cheng Fu, and today I will be sharing the topic on Wi-Fi. What is Wi-Fi? Wi-Fi is the radio signal sent from a wireless router to a nearby device, which translates the signal into data you can see and use. It is based on the IEEE 802.11 family of standards. The device transmits a radio signal back to the router, which connects to the internet by wire or cable. It is a low-power wireless communication used to connect computers, tablets, smartphones, and other devices to the internet. A router works as a communication hub wirelessly, and these networks allows users to connect only within close proximity to a router. Wi-Fi is very common in networking application, which allows portability wirelessly. These networks can be accessed by others, so we can use a password to protect its security. And Wi-Fi does not stand for anything. It often referred to as the below four kind of writing, and is often thought to be short for wireless fidelity, but there is no such thing. The term was created by a marketing firm because the wireless industry was looking for a user-friendly name to refer to some user-friendly technology known as IEEE 802.11, and the name stuck. Wi-Fi uses multiple parts of the IEEE 802 protocol family. Different versions of Wi-Fi are specified by various IEEE 802.11 protocol standards, with the different radio technologies determining radio bands and the maximum ranges and speeds that may be achieved. Wi-Fi most commonly uses the 2.4 GHz ultra-high frequency and 5 GHz super high frequency radio bands. These bands are subdivided into multiple channels. Channels can be shared between networks, but only one transmitter can locally transmit on a channel at any moment in time. There are multiple versions of Wi-Fi. To communicate, devices must use a common Wi-Fi version. The version differs between the radio wavebands they operate on, the radio bandwidth they occupy, the maximum data rates they can support, and other details. Historically, the equipment has simply listed the versions of Wi-Fi using the name of the IEEE standard that it supports. On the right shows the Wi-Fi generations. I will be sharing the working principle of Wi-Fi. For us to get Wi-Fi waveforms, we need to have Wi-Fi transmitters, devices like modems, routers, input source internet signal. Modem equipment. Router will take internet signal via wired connection and turn into radio signal, and send to devices used as smartphones, tablets, laptops. This is the process of receiving credit wireless signal, also called adapter, is the Wi-Fi card on a laptop phone, and transformed into internet signal. And this process is completely reversible, meaning the router, modem, receiver radio signal from the adapter and decodes them, sent over the internet. The range of the Wi-Fi is dependent upon the environment, indoor or outdoor ranges. The Wi-Fi cards will read the signals and create an internet connection between the user and the network. The speed of the device using Wi-Fi connection increases as the computer gets closer to the main source, and the speed is decreased the computer gets further away. Medium of transmission used. Wireless transmission is used of a unguided media. It involves no physical link built between two or more devices communicating wirelessly. Wireless signals are spread over in the air and are received and interpreted by appropriate routers. When antenna is connected to the electrical circuit of a computer, it converts the digital data into wireless signals and spread all over within its frequency range. Then the receptor collects these signals and converts them back to digital data. Radio transmissions are used to generate radio frequency. In addition, it is easier to use due to its large wavelength. It can penetrate through the wall and structures alike. Wavelength can have from 1 mm to 100,000 km and frequency from 3 Hz to 300 GHz. The types of modulation used. RF modulation is used. RF modulation transforms digital data, such as binary ones and zeros representing an email messages, from the network into an RF signal suitable for transmission through the air. This involves converting the digital signal representing the data into an analog signal. As part of the process, modulation superimposes the digital data signal onto a carrier signal, which is a radio wave having a specific frequency. In effect, the data rides on top of the carrier. To represent the data, the modulation signal varies the carrier signal in a manner that represents the data. The transmission rate is the speed that data is being transmitted from an AP to a wireless device. Example like 202.11n connections. The maximum possible rate is 300 megabit per second using 400 MHz and channel bonding. For 202.11 AC connections, the maximum possible rate is 1 gigabyte per second. Then what's the frequency spectrum used? Wi-Fi are mainly using two types of spectrum, often referred to as the 2.4 GHz and 5 GHz Wi-Fi band. 2.4 GHz is mostly widely used of the band suitable for Wi-Fi. It is used by 202.11b, G, and N, and can carry a maximum of 3 non-overlapping channels. On the other hand, 5 GHz can be used by 802.11a and N, begin at a higher frequency, having higher cost equipment, but can carry up to 23 non-overlapping channels, although it gives a shorter range than 2.4 GHz. In Singapore, the maximum transmission power used for 802.11b 2 GHz and channel 13 is 100 milliwatt, 30 dBm. And this will be the end of my sharing. Thank you.